Alright, so in the previous video we talked about modifying SGD using a momentum term. In this video we are going to take it a step further and talk about adaptive learning rates. But before we dive in, you might wonder what optimization algorithms do most people actually prefer in practice. So I found a paper where the researchers analyzed the usage of different algorithms throughout the years. So looking at the most recent entry here, 2020, we can see that SGD, stochastic gradient descent, is still the most frequently used optimization algorithm. The other very commonly used optimization algorithm is SGD plus momentum, which we just talked about in the previous video. And the third most commonly used optimization algorithm is ADAM. ADAM is actually the star of the show of this video, and we are going to talk about how it works in detail. So let's talk about ADAM, which stands for Adaptive Learning Rates with Momentum. So the key idea here is that we are automatically adjusting the learning rate during the training. So in particular, what we do is we decrease the learning, we slow it down, if the gradient changes the direction. Otherwise, we speed up the learning, we increase it, if the gradient stays consistent. So in a nutshell, we are paying attention to the direction of the gradient, and based on that, if it's consistent, we speed up the learning, the training, so to converge faster, and otherwise we take it down a notch. So how does this adaptive learning rate work? So to understand the ADAM algorithm, the adaptive learning rate with momentum, let's take a step back and talk about its precursor, the RMSProp algorithm. The RMSProp algorithm is actually very popular in practice, even though there is no research paper about it. How it works in a nutshell is that we are using the moving average of the squared gradient of each weight. So here's an outline of the RMSProp algorithm. In a nutshell, how it works is that we are using a moving average of the squared gradient of each weight when we do the updates. And we involve this beta term here, and beta is a hyperparameter that we have to choose. Typically it's a value between 0.9 and 0.999. So you can see here in this equation there are two major terms. There's the mean square term, and there's the gradient update here squared. So that's the squared gradient. We multiply the mean square term by beta, and then we add the squared gradient here on the right hand side. And the squared gradient itself is multiplied by 1 minus beta. So with beta we can kind of adjust how strong we weight these individual terms, the mean squared term and the squared gradient here. So essentially you can think of RMSProp as a scaled version of the SGD algorithm. So we are scaling the weight updates. At the bottom I'm showing you how the weight update looks like, where alpha is still our learning rate, and in the numerator here that's our regular SGD update. But now we have this denominator term here, which is essentially a scaling coefficient computed by RMSProp. So R stands here for the mean square term, and since we have a square root, we call it the root mean square. And then we have epsilon here, which is just a small value to prevent a division by 0. And yeah, this is how RMSProp works in a nutshell. It's essentially a modified or scaled version of SGD. And this scaled version involves the moving average. Now ADAM is very similar to RMSProp, except now in the numerator we have a momentum-like term, which is similar to what we have computed in the previous video when we talked about SGD with momentum. And in the denominator we have a flavor of this root mean square value, which is similar to RMSProp. So ADAM is actually a very popular choice in practice, and personally I like it a lot because it can sometimes be easier to tune it compared to regular SGD. So by that I mean it's easier to find a good learning rate using ADAM compared to regular SGD. Yeah, and to add a quote from this research paper I mentioned earlier, the authors write, ADAM remains a strong contender, with newer methods failing to significantly and consistently outperform it. So ADAM is actually a very popular choice that works very well in practice. So how can we use ADAM in practice? Again, it's actually very simple using ADAM in PyTorch. We just swap out SGD with ADAM here. Of course, ADAM has a few hyperparameters. There are two beta terms in ADAM. However, usually most people use just the default parameters. Now, ADAM has this adaptive learning rate concept, and you may wonder whether it makes sense to use a learning rate scheduler. In my experience, it can still be worthwhile using a learning rate scheduler even if you use ADAM with an adaptive learning rate. So here I'm showing an experiment I ran with ADAM, and at the top is the plot for the training set loss and the validation set loss. At the bottom I'm showing you the training set accuracy and the validation set accuracy. And now when I add a scheduler to this training procedure, you can see that the results are much improved. Alright, and this is in a nutshell how the ADAM algorithm works for adaptive learning rates. In the next video, we will talk about activation functions.